Howdy YouTube land. Been about a year since I've done any videos, but this video I'm actually going to be talking about my long-standing Zephyr 1100 project. This one's been going for a long time. This time last year, as you do at the end of the COVID thing, having a look at your life a bit, I realised it'd been 4 years since I'd even put a spanner on my project bike. And it being the one that started all of my journey with motorcycles and modifying them, I decided to basically take a year off from everything else, and with increased work commitments and other personal matters, I tinkered along with my Zephyr 1100 project. So about this time last year, I sat down and pulled off the covers and had a look at what I wanted to go on with. Now, one of the long-term parts of the project was, of course, the wiring system and the ignition. Very much the ignition, which brings me to the point of this video. But we'll come to that. So I sat down and decided to actually design and spec my wiring harness and how I was going to go about this build. Here we are a year later, and I haven't run a wire yet, but there was a massive amount of work that needed to be done before that was even possible. Maybe if this goes well, I'll do some more videos about a lot of it, but I'll break it up. In this first video is about the ignition system and some of the peculiarities with the Zephyr 1100 format. So I'll turn the camera around and we'll have a chat. The dog said hi and I had to come give her a pat because she's a pain in the ass, aren't you, darling? But anyway, so not a lot's changed. Pretty much where I spend most of my time, but a lot of people would know that I've been building this for probably, actually it's about 17 years now. But this is my Zephyr 1100. Very much. Okay, so the bike's been a roller for probably quite a while now. So most of the running gear's all in the right place. And in the whole saying of the last 10% of the job is 90% of the work, I decided to attack systems, all the things that you don't really get to see a lot of, apart from silly things like aluminium bent brackets to get the reservoirs to sit where they needed to be on polyurethane rubber isolators. Actually factory reservoirs, factory hose, factory fittings, factory master cylinder, just drilled and tapped into the body and mixed and matched the parts from the factory and just made those brackets. There's just been a lot of things like that have really eaten up a lot of time. But like I said, today I'm going to talk about the ignition system. Now these are, well, mine is a 92 Zephyr 1100. Now all of the Zephyr 1100s have a unique type motor in them. The bottom end's actually, I think it's a VG 1200 Voyager water-cooled motor, but Kawasaki put their own oil-cooled top end on that block and came up with the Zephyr 1100. Now, when they did that, one of the things that they did was they made it a twin plug head. So you can see in there, you will when I get the light off, there's actually 8 spark plugs for the 4 cylinders. Used a lot in drag racing, especially in Kawasaki land, to get an increase in compression you could run A lot of people used to run a twin plug head. The 2-valve of the Kawasaki doesn't handle the same compression as the 4-valve Suzuki's at the same time did. I don't believe that's why they were doing that particularly much, though this does have a factory a lot more compression than its counterparts in the air-cooled Kawasaki range of the early 80s, but that wouldn't be unusual because engines had come a long way since then, even though that these, the 1100, were probably a little bit underwhelming in their performance. Again, when I do a video about the motor, I'll actually go into some very deliberate design choices, I believe, to offer a certain type of riding experience that the Japanese were going for when they designed the motor. But being a twin plug head means that aftermarket ignitions become a little bit more limited in what you can do. I'll strip some of this gear off and we'll start having a look. So you can actually see now how there's 2 spark plugs per cylinder. So 8. Now the factory has, like this setup has, 4 coils, pretty much standard coils. You've got your twin out of, say, the 4 spark plug of pretty much all the Japanese bikes. So there was twice that, so they had 4 of them. Now, they were going to cut with what I'm going to do with the motor. The compression, the cam, the actual size of it would have really been limiting. So in the air-cooled Kawasaki world, our go-to has always been one of these, Dyna 2000. They actually stopped making them for a while through COVID. I hope they're still made. I believe they may be making them again, but this is anyone that's had 90s Japanese bikes. People were using them long before the 90s. So the Dyna 2000 is just their module one, just a box. You put a pickup on the motor. If that will focus. On the right hand side is an RPM limit. On the left hand side is a selection of different ignition curves, and the red light in the middle is for timing, with pressed together cranks instead of forged cranks. You genuinely have to time the ignition, the pickups, so that in case the crank isn't properly in alignment, you can still have the ignition igniting it at the right time. Basically, you degree the motor to the ignition. A plate that can turn with then pickups that can move individually, and then you play around with it and you get it on the motor. Now, these have been great, and we've always had the different impedances of ignition coils. This is a classic Dyna that has been used forever by everyone. Grey ones are 2.2 ohm. Now, the reason that the 2.2 ohm is actually important is the reason that there's some peculiarities when you run an 8-plug head on a 4-cylinder motorcycle. This box takes an input and via the coil triggers the coil. Now that's done by some electronics inside. Like anything, there's only so much they can deal with. So the impedance of the coil is how much resistance does it take to trigger the coil. So the lower the resistance, the faster and stronger the trigger is, and higher output, but a higher energy throughput. So any of the aftermarket ignitions have a maximum of impedance that they can deal with before you burn them out. Now in racing, there's the Dyna 4000. That is actually designed to run very low impedance through, and then you step up into the land of racing stuff where they're all designed to run low impedance for big fat sparks everywhere. So around the 2.2, 3 ohm, two of them, Dyna 2000, a four spark plug motor, beautiful. If you put two more in, that halves it, 1.1 ohm, which is almost a short circuit. So 0 ohm is no resistance. That's as if we put the battery and the negative and just fried the bloody thing. So there's a couple different ways to do it. It is to have a unit that is dedicated to run 4 coils, or by using parallel and series wiring of the coil itself, those 2 pins there. You use Ohm's law and you come up with an impedance that's suitable for the ignition to deal with. Very much if you've been into audio, the way that you would series and parallel wire speakers so that the impedance of the speaker doesn't get so low that it will burn out the amplifier. Very similar in the semiconductor way that they do that in these triggers. That's what happens. So I was going to use the Dyna 2000, parallel and series wire the coils, and happy days. Everyone has used them forever. They are bulletproof, very reasonably priced, amazing product. Now, on my trips to Japan though, I seen an equivalent, that little blue box there, the SP2, and it is a Japanese equivalent of the Dyna 2000. Now, one of the beautiful things about this is you can't see it, but up on the right hand side of that plug is exactly the same as a Dyna 2000. Very simple. You go through what ignition curve you're going to run, what RPM you'd like the ignition to stop it. So really cool packaged, very popular in Japan, just a touch more expensive than the Dyna, but I actually went with this because I was in Japan and I could buy the bloody thing. But this is made specifically, this model is made specifically for the Zephyr 1100. Even though the rest of the world, we only got the Zephyr 1100 for a couple of years. The bike was actually produced from 92 through to 2007, was a very popular model in Japan. So their aftermarket on this, some of this stuff is just a little bit more available. Now, one of the things about the SP2 kit came with these beautiful little mini coils, 4 of them. One of the beauties is it's actually a plug-in module, basically, for the Zephyr 1100. So if we come over here, that is the plug for the back of the unit. And these are the plugs that the factory ignition system plugs into the loom with. So you plug those in, you plug the other end in, and it is happy days within reason. Patch leads to plug into the coils and actually into the factory harness. Now, for many reasons, I'm not keeping the factory harness. This in itself created its own flow-on effects, but in regard to the ignition, I actually had to just sit down with the factory manual, the factory loom, and this patch lead. And what I came up with is this, where I pretty much just pinned out which every wire goes from and to from the factory harness. And then through my other harness, I've integrated it in. But another one of the advantages of the SP2 is the fact that under this cover, if I can take it off at some stage, is a reluctor pickup. Now the Dyners, you get a backing plate and a pickup that, or a button, I should say, that goes onto the end of the crank and triggers the Hall effect pickups to trigger the ignition. Now, because the Zephyr 1100 was never released with a Dyna kit, I'd have to adapt a backing plate and a trigger button from another model. Because the reluctor style of pickups are not compatible with a system that works with Hall effects. So, out of there is a factory cable. And because the SP2 kit is designed to plug into the factory harness, it's actually been configured to use the reluctor circuit from the factory bike. So it actually saved me a considerable amount of effort. Again, maybe later on I'll take that cover off and give you a quick look. But again, I had to sit down and actually, through the wiring diagram of the factory bike, the loom and all of the pins, work out which one they go into. Now, again, that brings me on to part of the reason this is all taking so long is normally what you do is, you know what those colors are, you snip that, you put this loom into the loom that you're running on the bike, heat shrink it, tape it up, happy days. Now, this bike has always been about evolving the way that I do things, and it's part of the reason it's taken so long. I really would just like to take advantage in just how available a lot of the products are now to just take things to the next level. So again, if we come over here, there's in here, I can't find any, yes. So everyone now is pretty much aware of like the Deutsch connectors that are available. But with a bit of searching, most of the connectors used on everything are not the manufacturers, but a broad item. So a bit of searching around, this style of plug that the SP2 uses is, well, one of these. And from a place in England, that was probably about $35 Australian. I picked up that as a kit, so my wiring harness will actually go into the new plug in the correct pins, and I will delete all of the splice joints that I would have needed through the whole system to do that. So again, a heap of the time that it took to actually get where I am going. Now, again, one of the big issues on running a plug head is actually physically fitting the bloody shit in. So I'm going to be using RS mechanical carbs on this bike. I really would like something nice, but I have sets of these, and one of the sets put aside for this, and it's just hard to argue with the price. So miles better for a lot of different reasons than the factory carbs. Again, when I'm doing the motor stuff, I might even cover some of that. But so these are RS 38s that I'm using on the bike, and they do have the option to put the pull mechanism on the outside, but I decided to keep the inside pull. So to allow that. Now, by good luck, more than good management, the ZR, the bloody 1400cc fucking superbike thing. Anyway, late model EFI with a bit of adaptation, I actually got the factory cables to fit. And then I had to fit 4 coils, so none of that touch. Now, all of these is actually, I've mapped the whole surface to the underside of the tank. So I've got 20mm clearance there, 20mm of clearance there. We're down to 15, 20, 20, sort of 18, 17, 10, 18. So that's all mapped. Now, I don't have an airbox now. I just have a bulkhead under there. So all the cables need to go somewhere. Now, in the factory, they have a big bundle that just goes all the way up here, and didn't allow for, I wanted to be able to still get to all the adjustment points that I need to for that carburetor, so without putting any wires in here. So these aluminium is just for wiring harnesses, some of the switching, these ones for the dash. Underneath here will be the other ones for the rest of the controls. So I'll pull them off now, and we'll have a look at how I've mounted them and how I've routed some of them. So these are the 4 SP2 coils. Now, these are the factory coil mounts, except they used to be flipped, and the coils were actually, to get it all to fit, staggered down the bike, which didn't really work for me. So I love just reusing standard brackets. They're normally really interesting and well made. They've got the returns. It was just easier. I just turned them, flipped them over, and machined up little adapter plates for the coils, so that when they all go together, you can actually see there's air gaps between all of them. Now, each coil has 2 spark plug leads. It goes off to the 8 spark plugs. Now, the spark plug leads, when I brought the SP2 in Japan, I also picked up from another company, PAMS did a high quality spark plug lead and the right resistor caps to suit the SP2. So I actually spent like a drunken sailor and I brought them. Ended up costing me about $400. And when I actually looked at the NGK good quality caps, I didn't like them. So I've always liked the factory style full rubber ones instead of the hard plastic. So it was about $400 just for the spark plug lead, the heat sheath, and the boots to go onto the coils. I thought I was mad, and after getting the 8 spark plug leads in and around and everything, I am so glad I spent the money. This is a 7mm cable, copper core, but just is the most amazingly flexible, supple, beautiful, absolutely beautiful. And when you put their supplied heat sheath and their boots, it actually makes a very nice combination. So these boots and the spark plug into the coil, underneath those boots is dilated grease. There's grease in the joint, so that's actually a watertight, weatherproof connection to the coil. And the same with the, again, I'm mad. I wasn't going to use my second hand, even though they were in nice order. I actually brought 8 of these. You can still buy this particular part number, but it's on single cylinder and twin cylinder, bloody enduro and farm bikes and things like that. It's $75, I think I got them for each Australian. Don't do the math, I'm an idiot, but again, I really like them. That spark plug lead is pushed down in with the copper core going onto the spike of these factory ones. Each one was actually filled with dilated grease while I was at it. So one of the other things that's been taking me forever is actually everything is run because it's all so tight, and I still wanted to keep things like you can see on that plug, I can show it, clearance, that nothing is touching. There's air gaps on everything. So I heat sheet, I use dual wall epoxy heat shrink for all of the stuff I do now. So to keep the heat sheath in place, I actually used good quality epoxy heat shrink the ends, and also heat shrink the ends there to make them actually like a loom. Now, I don't know if you can see it. There's one of them. Actually, if we come back here, these little loops I've been welding all around the frame to take surfaces, so that there is some high flex silicon, I believe that's 8 gauge cable that's coming to the M unit for the positive and negative connections. But I'm able to then zip tie wherever I like. So that run of the accelerator cable is actually clear of all of the wires. So there's actually no chance of any rubbing between vibration of any of the surfaces, be it accelerator cable, vacuum lines, or in this case, spark plug leads. I set myself the goal that none of the surfaces would have to touch and rub each other. So that means that in behind that coil is some of them to actually take the wires, the spark plug leads, out through and out this side. The same on this side to get around there. Under that coil is some. You can actually see there's actually a little aluminium bracket that bolts onto a couple of cover bolts that gives me a place to run that line, so they can all come up to the front of the bike here and be where they need to be to actually cross over and go where they need to go. Again, I'll probably put up some photos, but a stupid amount of time to make that aluminium bracket. It's actually two-piece. The top piece is the cover, so it's there as a way of keeping all of that and all of this exactly in the right place, so it doesn't rub on or be in any way not be serviceable for a long period of time, because this is what I set myself for this bike. This is my permanent ride bike, It was my first, and I'm building it that I never have to touch it again, hopefully. Fingers crossed. So there's actually one of those on either side. So all of those wires, all of those spark plug leads I should say, actually come and go to their respective coils, and that probably took me 3 months. It's stupidly time consuming for something that when the tank's on, yeah, it looks like I ran some neat spark plug leads, but yeah, well, it's my bike and I'm silly like that. But like I said, the main aim is actually, that's why less splices, more cable management. A lot of things I'm doing on this bike really revolve around the fact that lessons learned, and I'd really like to not have to touch some of this ever again. Once it's on the road, I really just want to ride it and put fuel in it and not care about it. So even though that's anal retentive, it's all towards actually achieving that with a little bit of my flair. But the whole thing starting to come along. Things like the bulkhead is now made, mounted. That's the overflow from the underside of the tank for when you spill into when you're filling the bike. Actually comes down now and on a fabricated aluminium that bolts onto the bulkhead. These factory have underneath that cover as a factory catch can that used to go into the airbox. It's a big open area in there with mesh, so the vacuum and the pressure of the motor go into it through the mesh, dribble back out, and it's actually integrated into the case. But what I've done is actually welded that tube on over on the other side. You can actually see because there's a hose that goes between them, and I've converted what used to be a little place for the ignition, that's going to be a secondary catch can. All the fabrication for the battery, it's just been a lot of work. Lots of little knickknacks everywhere, but this video is probably getting a bit long. But now for the next one that's going to drive me nuts, how to mount that bloody guard. I've been staring at it for 4 weeks now. But anyway, hope everyone's not bored to shithouse. Catch you next time.